Okay, we made it. We're at the last section about trigonometric identities. We're on section 5-6, which are half angle identities. So again, in 5-5, we saw we could take our angle theta or A and double it by multiplying by 2. If these are half angle identities, we're doing the opposite. We're not taking the angle and multiplying it by 2, we're dividing it by 2. Half, that's where we get the word. Half angle identities. And we have it for sine, cosine, tangent. Again, you don't need to memorize these identities. Memorizing is obsolete. It's learning how to use them. There is a proof of one of these in your notes. You can look it over just to see that they just didn't fall out of the sky, that they came from a development. But let's see how to use them. In your notes, let's go to example 1b. If I want to look up the sine of pi over 8 without a calculator, well, first of all, pi over 8 is in radians. We need to switch that to degrees, right? So we know pi stands for 180 degrees, and 180 does not divide by 8 evenly. 8 goes into 18 twice with 2 left over. 8 would go into 20 twice, 16 with 4 left over. So that's roughly 22 and a half degrees, or 22 and 5/10 degrees. So that angle in radian measure in decimal degrees is 22.5 degrees. Well, we all know we cannot look up the sine at 22.5 degrees using the unit circle or using our 30, 45, or 60. So again, we're back to that same whole dilemma. If the calculator wasn't there, how could I look up the sine of 22 and a half degrees? Well, if we think, okay, this is an angle that you could look up, because if you take half of one of our angles we know, it will make 22 and a half degrees. What angle can we take half of to give us 22 and a half degrees? That's right. We can take half of 45 degrees. So do you agree if I take this one angle, A, and I write it as 22 and a half degrees is really 45 degrees divided by 2. Now I have a half angle identity because I took angle A and I divided it by 2. Make sense? So I know to look this up, I would need this identity. It's got a plus and minus in front of it because it's a square root, and we'll talk about which one's which. And here's our formula. Our identity says 1 minus cosine A over 2. So what you've done, guys, is angle A is no longer the 22 and a half degrees you cannot look up. You're saying angle A is 45 degrees. Because if you take angle A 45 and you divide it by 2, you'll get back to this. So I'm going to replace in this identity angle A, which I now know is 45 degrees. You all agree with me? You're saying an angle divided by 2. What angle do I divide by 2 to make this? What would go in this spot would have to be 45 degrees. So if you're saying A is 45 degrees, when you substitute in the identity, A is 45 degrees. We know we can look up 45 degrees because that is off our 45-degree triangle. 45 degrees in quadrant 1. We know our sides are 1, 1, square root of 2. We know to do the cosine of 45 degrees is adjacent over hypotenuse, or x over r. So this is going to give us plus or minus square root of 1 minus. We're not going to write 1 over square root of 2 because we're going to rationalize that to be square root of 2 over 2. Everybody good? That was the thinking part. What angle can you take half of to give me this pi over 8, this 22 and a half degrees? Once you get here, this is arithmetic. You can't leave that answer like that. We got to do our operations. Well, you can't square root till you have one number inside. So you got to work with a numerator and you got to subtract. In order to subtract fractions, you need a common denominator. So we got to change 1 to 2 over 2. Do you all agree with that? So now inside the square root, you have 2 over 2 minus square root of 2 over 2. We could put that together as one fraction. The denominator would be 2. The numerator we cannot subtract. You cannot subtract a whole number from a root, so you write 2 minus square root of 2. But that's still over 2 people. Well, we can't leave that. Now we have a fraction divided by a fraction inside the square root. So we have to simplify that. So we come over here and we say, okay, we have plus or minus the square root. We have the numerator 2 minus square root of 2 over 2. We want to divide by 2. But in fraction land, dividing by 2 is multiplying by a half. You all agree? So now inside the square root symbol, we got to multiply fractions. Top times top, bottom times bottom. So now the denominator becomes a 4. Everybody's good? That's still not good enough. Now that you have a fraction, one fraction inside the square root, who owns the square root symbol? Well, that square root symbol belongs to both. It belongs to the numerator and it belongs to the denominator. So in the numerator, you have the square root of 2 minus the square root of 2. In the denominator, you have the square root of 4. Okay. Can you square root 2 minus square root of 2? No, you cannot. So we have to leave the numerator. The square root of 2 minus square root of 2. But in the denominator, the square root of 4 is 2. Now I know what you're thinking. You're thinking I'll just divide out all those 2's. No, you can't divide this 2 with this 2 because this one's in a square root. This one is not. Okay? That is your final answer except for the sign. You've got to decide, is the answer positive or negative? Well, you've got to think what your angle measurement was. Your angle was, you started with 22.5 degrees. Would the sine of 22.5 degrees be positive or negative? Well, 22.5 degrees is in quadrant 1, so that answer would be positive. So this is not hard, it's just a lot of arithmetic. You got to go slow and watch your arithmetic. All right, let's try one more example in the notes. Let's go to 2a. Okay? Okay, example 2a says, find the following. Find cosine x over 2 given cosine x equals 1/4 and 0 less than x less than pi over 2. All right, so our last example we're going to do with identities. Yay! We want to find the cosine of x over 2. So we know this is dividing by 2. This is a half angle identity. Okay, so we go here. There's only one choice. All right, we write it down. So you write cosine, they're using x. X over 2 equals plus or minus square root 1 plus cosine, they're using x over 2. That's the identity we have to use. In order to use this identity, either A, we'd have to know actually how many degrees angle x is, which we do not. We know angle x is between 0 and 90, but we don't know exactly how many degrees it is. Or B, we'd have to know what this trig expression equals. Do we know what cosine x equals? Sure we do. It's told. Cosine x is 1/4. So now we have a substitution. This is plus or minus the square root of 1 plus 1/4 over 2. Isn't that great? Now again, we're going to add, we need a common denominator inside. The common denominator would be 4. So this becomes 4/4 plus 1/4, which is 5/4, divided by 2. But you can't leave two fractions inside the square root. 5/4 divided by 2 really means 5/4 times the reciprocal, multiplicative inverse, a half. 5/4 times a half is 5/8. So you get plus or minus the square root of 5/8. Can't leave 5/8 because you got a fraction. So that means the square root belongs to the numerator and to the denominator. Can't leave that because all roots have to be reduced. Can't do anything with the square root of 5. 5 is prime. But 8 is 4 times 2. And the square root of 4 is 2 over the square root of 2. So square root of 8 is really 2 square roots of 2. Can't leave that because you don't have a whole number in the denominator. So we rationalize by multiplying by square root of 2. So square root of 5 times the square root of 2 is square root of 10. Square root of 2 times square root of 2 is a 2, and 2 times 2 would be 4. But now we have to make the decision. Is the answer positive or negative? Again, you got to look at your information given. It says x is between 0 and pi over 2, which is 0 to 90. 0 to 90 puts you in quadrant 1. In quadrant 1, every trig function is positive. So again, it's not hard to work these identities. It's just a lot of arithmetic. Be careful. My last note before I leave identities, if you look at the half angles for tangent, there are 3 choices. And the rule of thumb is, guys, to keep it as easy as possible. If you look at these 3 choices, the one that I would never try to use is the one inside the square root, because we have so much work to do. The other 2 are pretty nice because they're both fractions, but there's a big difference. In the middle one, there's 2 terms in the denominator, and in the last identity, there's 1 term. So if you're asked to get a half angle for tangent, the best choice is this identity. All 3 work, but that one is the easiest to work with algebraically to do your arithmetic. Okay, we are now finished with the chapter on identities. Now we will move into chapter 6, where we use these identities to get to our goal, which is to help us solve trigonometric equations.